Why does ground light occur before an earthquake? As we all know, before earthquakes arrive, special abnormal phenomena often occur. For example, a magical sea of clouds appeared in the sky, abnormal roaring of livestock on the ground, sudden fluctuations and heating of groundwater level, the birds in the sky have abnormal mournful cries, and so on. In the footage captured by the camera, we unexpectedly saw a strong flash of light on the surface before the earthquake, shining the entire horizon. We cannot help but ask, what is this flash of light? Is it a sign before an earthquake? Ground light refers to the light that appears above the area affected by the earthquake during its occurrence. The occurrence time is mostly at the same time as the earthquake, with a duration ranging from a few seconds to several tens of seconds. Moreover, the shape of the ground light is not singular, with common shapes such as flash, scattering, strip, column, arc, and sheet. At the same time, its colors are also diverse, with common ones being red and blue light. Of course, in some cases, yellow and green lights may also appear. For example, the flake-shaped light, arc-shaped light, and strip-shaped light that appear in the low-altitude atmosphere are mostly bluish-white, while the fireballs and fireballs that appear on the ground are mostly red. Before the 2008 Wenchuan earthquake, some photography enthusiasts unexpectedly captured another magical image. In the picture, we can see that the ground light is not only the light coming out of the ground, but also the sky. And this time, the colors are even more magical, presenting a variety of colors similar to rainbows, with a somewhat peculiar shape. After seeing a series of photos of the ground light, we couldn't help but ask, what exactly is the reason for its magical scene? Is the size and brightness of earthquake light proportional to the earthquake energy and magnitude? Scientists have varying opinions on the causes of ground light, and there is currently no definitive conclusion. Because earthquakes are difficult to predict, and science requires repetitive experiments. Obviously, using earthquakes for repetitive experiments sounds like a fantasy. However, regardless of the statement, it is necessary to think from the perspective of energy. Earthquakes contain enormous energy. A magnitude 7 earthquake is equivalent to 25 Hiroshima atomic bombs simultaneously rapidly releasing energy, so regardless of any theory, when seeing light, one must think in the direction of electricity. At present, the mainstream explanations for ground light in the scientific community mainly include the following. 1. Oxygen ionization. Some scientists believe that ground light is the ionization of oxygen. In many geological structures, rocks contain a large amount of oxygen element, and the strong stress generated during earthquakes can be strong enough to ionize oxygen atoms and carry negative charges. After the negatively charged oxygen atoms are squeezed out, they will ionize the air and produce plasma when they enter the atmosphere. The plasma will emit a strong light. 2. Piezoelectricity. Geologists say that in areas where earthquakes pass, there are many crystals underground, such as quartz. The internal structure of a crystal is anisotropic, and applying pressure to this crystal material has a high probability of generating a voltage difference. Because quartz crystal belongs to single crystal, its shape structure is hexahedron. The piezoelectricity produced by the force along the x direction, electric axis, is called longitudinal piezoelectricity. The piezoelectricity produced by the force along the y direction, mechanical axis, is called transverse piezoelectricity. For example, the quartz watch we wear utilizes this principle. 3. Earth's magnetic field. The physics professor of the University of California believes that the Earth's light is related to the Earth's magnetic field. The charged particles generated by earthquakes converge and interact with each other under the action of the Earth's magnetic field, emitting light, similar to the principle of aurora. However, it is evident that auroras generally only appear in high-latitude areas between the North and South poles. Most of them are located near the equator, far away from the poles, and there will also be the appearance of ground light before earthquakes occur. This theory is clearly flawed. 4. Frictional electrification. Terita, a Japanese scholar, said that under the action of seismic wave, the rock has strong friction, which gathers a large number of charges and produces high-voltage discharge. Within the depth range affected by earthquakes, rocks are compressed and moved, generating flowing potential. Temple Tien speculates that the pressure on the rock is equivalent to the pressure generated by a 100 km rock pillar. According to calculations, the potential difference it generates can reach 3 million volts. Obviously, such a huge potential difference is enough to cause high-altitude discharge and form ground light.